Hello, my name is Daniel Gopar, and this is the second video on the Elisp tutorial, and we're just going to go over some things I forgot to mention in the last video, and one of them was how to create a variable. So one way to create a variable is by, of course, using parentheses, and then using the set q command, space, and then we're going to use my dash bar right here, and we're going to set that to 90. So notice how I use dashes instead of doing like capitalization or underscore like in some other languages. In Lisp we usually just use dashes. Yeah. So if we press enter, ta-da, it gets evaluated to 90. Also, setQ has the ability of setting multiple variables. So for example, let's say you do my other bar and set it to 10. Bam. So it just returns the last thing that it was set to. So now I can do stuff like my bar and my other bar, and that should equal 100. Ta-da, 100. Alright, cool. The next thing I want to go over is over Booleans in Lisp. So for a true value, it's just T, and if you press it, it's valid because it's true. And also for false, it's nil. So there you go, nil. And one way to test for this is there's a function called null, and it returns true if it's false. So nil, is this false? Yep. Is true false? Nope. It returns nil. So yep, there you go. That's one way. And let's see. Next is lists. So a set lists. Yeah. So you know how I said that we're going to use parentheses for everything? Well, yep, a list is also a parentheses. So let's say I want to make this a list. If I press enter right now, Emacs is going to try to evaluate that, and it's going to think that 1 is a function, and we already know what that happens. It gives us an error. So yeah, it says 1 is not a function, and we know that. So one way to tell Lisp that, hey, the stuff that I'm about to give you is just data, don't evaluate it, don't do anything to it, it's just a list, and leave it as a list. And the way we do that is by a single quote. That single quote right there. So now, if we press enter, it will just spit back the list. Boom, like that. Exactly like that. Also, one thing, now that you know how lists, what are lists, an empty list also results to false. See, it's false. So if it's equal, nil, I think this should work. If not, then I'm sorry, because I'm horrible for not checking first. Yeah, so see, nil is the same as an empty list. So keep that in mind. Alright, cool. So now we know how to use a list. Let's set it to a variable. So my list equals 1, 2, 3. Ta-da! So now if I evaluate my list, it's just 1, 2, 3. How awesome is that? Alright, cool. So you're saying, okay, now we know how to create a list, but how can I add stuff to it? Well, that's easy. We can do this. Add to list, and we do my, pay attention to that single quote right there, my list, and then we'll add 4 to it. Ta-da! So now 4 has to it. So if I evaluate my list, the 4 is there. So this actually modifies the list. And there's also another way, which is called cons for construct, I believe. And we can give it 5, and then we'll just pass in my list again. And there you go, 5. But this does not modify the list. You see, my list is still unchanged. This simply creates a new list with the 5 added to it. So, you know, you got to remember things like that. Or just look at the documentation to make your life easier. So yeah, just keep that in mind. Now, to get elements from the list, we use something called char. So this returns the first element in any list. So the first element in my list should be 4, right? So we do char 4, bam, look at that, it returns 4. And also to get the rest of the list, we do cdr. So that returns everything after the first element. So it just removes it. So yeah, that's kind of the way how we traverse through lists. It's kind of weird for people who are new to it. But yeah, I mean, it's just it's just another way of thinking. That's pretty much it. But I mean, once you're comfortable, it's pretty much the same as any other language. And of course, there's something called nth. Nth, and then you just give it the index of the list. For example, let's go with 0. And when we do my list, oops, why do I keep pressing Y? And my list, and it should give us 4. And if we do 3, it should return us 3 because that's the index of 3. Yep. So 0, 1, 2, 3. Yep. There you go. So that's pretty much it. 6 minutes. Alright, let's do a little function. Now that you know how lists and everything work, we're going to create a little function that checks if a number exists inside a list. And so that function already exists in Emacs, in Lisp. It's called member. So let me just show it to you. Member, let's check if 4 belongs in my list. My list. And it does. So if 4 exists, it just returns the list. But if it doesn't, if I put 8, it returns nil. So we're just going to create a simple little function that checks if the number exists. And then, of course, after we create the function, we're going to create a test, because code without test is not very good. So, alright, let's do defun does exist. And then we're going to pass in a number and some list. Oops. Why do I keep pressing Y? It's weird. Alright, cool. So defun, why is it not coloring? Huh, weird. Whatever. Alright, so after that we're going to call in the member function, and we're going to do some number inside of some list. That's pretty much it. Bam. So now, instead of member, we'll call does exist, and it should return nil. But if we do 2, look at that, it returns the list starting where the element is found. So it works sweet. So that's one awesome way to do it. Of course, this is a pretty much useless function since member is already defined right there, but it's just as an example. Alright, so let's do the testing. So as always, we do require ERT, bam, to call it in. And then after that, we do ERT def test check number. I don't know, horrible name, but whatever. And then what we're gonna do is we do should, let's see, where am I? Should a call to does exist with 1 inside of a list of 1, 2, 3 should be true. And let's test that. And let's do metax ERT. And then we're gonna do specific, check number, and ta-da, it does work. Sweet. So we can also do does check 5, and we should wrap this up in not. So that just returns the opposite. If it's true, it converts it to false. If it's false, converts it to true. Pretty much. So this should be right. So let's do ERT again. We're gonna check number, and bam. Ta-da. Of course, you can have multiple tests inside the test case. Oh, dang it. Why does this thing evaluate on enter? So let me do should, and then does exist 45 and 90 or 30 or whatever. Bam. So now I have 2 test statements, and it should still work fine. Ta-da. So yeah, that's pretty much it. Alright, sweet.